Hello and welcome, lazy chemist, to today's lecture on the energy levels in an atom. Today what we're going to do is explain how atoms have energy levels and how those energy levels correspond to the electron and where the electron likes to sit. Okay? So, we're going to go ahead and be talking about the arrangements in atoms or the arrangement of electrons in atoms. And in general, we're going to be using the Bohr model for this. Okay? Now, I know that we went over many different models of the atom, but the most useful model for us to go ahead and think about this, at least in this level of chemistry, is the Bohr model. And in the Bohr model, we have a couple of assumptions that we're going to make. And that's that the electrons can inhabit multiple energy levels around an atom. The lower energy levels are closer to the nucleus. And actually, I should go ahead and correct that here. That's my mistake. Lower energy levels are closer to the nucleus of the atom. Okay? And that higher energy levels are further from the nucleus of the atom. Okay? And we're going to go ahead and have a couple of different energy levels here for us to go ahead and take a look at. And the first energy level is going to have 2 electrons. The second energy level we're going to have is going to have 8 electrons. And then the third energy level technically has 18, but we also say that it has 8 electrons, which for most of our purposes is going to be just about right. Okay, and then the fourth one we're going to go ahead and say that has 18. Okay, and this will come into play in just a little bit here. Okay, and this is what's called using the Bohr model. Okay, and what's going on here is that Bohr ended up discovering, or it was actually discovered much earlier than Bohr, but Bohr ended up explaining that we would end up getting specific wavelengths of light. Okay? And what would happen with those wavelengths of light is that the light was actually being produced by electrons moving up and down energy levels. Okay? And what would happen is that an electron, if it was excited, it would be at a higher energy level, and then when it cooled down, it would shoot off some light from that energy level. Okay? And that light was always a direct wavelength, and it had to do with the fact that it was always the same distance that it was going down. Okay? And so when we think about these energy levels, what we want to think about them as is kind of like a stepladder. Okay? So that analogy is going to go ahead and help us out, especially when we think that, okay, the electron can be here or here. Kind of like you can step on a stepladder on the first step or the second step, but you can't step in between. And that's what's really going on here with our atom and where the electrons like to live. They can only live in these discrete little energy levels and nowhere else. Okay? So it can be here, right at this line, or here, or here, or here, but it can't be anywhere in between. Alright? And we discovered that basically just because, we would heat up some atoms of different substances, and no matter how much we heated them up, it would always give us the same wavelength of light coming out. Okay? And you guys can see this all the time, especially if you ever go anywhere that has any neon lights. Neon lights are a great example. When we heat up and energize the atoms of neon, what will happen is that we'll get an electron to go from a lower energy level to a higher one, and then when it cools down, it'll release red light. And it doesn't matter how much energy we give to that neon, every time that neon goes from high to low, it'll release red light. Okay? Now, The next and probably the most important thing is being able to draw out and indicate where these electrons are in terms of their energy level. Okay. Now, the energy level is going to be directly correspondent to the elements on the periodic table. And the first row has 2 electrons max. So this is just like here. The first energy level has 2 electrons max. And then like the second row has 8 electrons max. Okay? What we're going to go ahead and do is anytime that we have to draw an atom, what we're going to do is we're going to draw a nucleus in the middle. We're going to go ahead and describe that nucleus. And then we're going to go ahead and use an X on the outer ring, on each outer ring to represent each electron. Okay? So that means that if you have an atom that has 7 electrons, you're going to end up drawing 7 X's on there. Okay? Alright. So, no, we're not going to do that one yet. So, what we're going to do is we're going to go ahead and first let's get rid of this one. Ooh. We're going to pick out a atom at random here. And we're going to go ahead and pick out, let's go with aluminum. Big fan of aluminum. Alright, so aluminum is going to be the atom we're going to pick, and it has 13 total electrons. Alright. So what we're going to do here first is we're going to go ahead and write out our middle part for the atom. And we're going to have aluminum. And we're going to say that this is aluminum 26. Okay. And we're going to draw the nice little nucleus here. Then we'll go ahead and draw out our first energy level. And we're going to draw our energy levels in red. Okay? And this is just to help further. You don't have to use these colors when you draw it out. And for our electron, we're going to go ahead and draw them out as magenta. Or no, let's go ahead and do purple. Yeah. Okay. Now, this atom, we put aluminum 26 because that's its weight. But as we said before, it has 13 electrons. So we're going to draw 13 electrons. Okay? We're going to start with 1, then 2. And then this is it. Our outer level here is full. So we're going to have to draw another energy level. Okay? So now we're going to go ahead and draw. We're not going to freak out. There we go. So we're going to draw another couple of electrons. This level, the second energy level, we said can go ahead and have a total of 8. So we're going to draw 8. Okay? Alright, so right now we've drawn 8 on the outside. We have 2 on the inside, so that way we've drawn a total of 10. But aluminum has 13, so we're going to need... Oh, we did the wrong color. So we're going to need 3 more. Alright, and then this is going to be our indication of how many electrons are around aluminum. Alright? And this is as simple as it is. It's just making sure that you have the electrons in, the right number of electrons in each energy level, and then going forward from there. Alright, so next, what I would like for you guys to go ahead and do is I'd like for you to go ahead and try on your own to do chlorine. So I want you to draw chlorine, And then I want you to especially take note of how many electrons it takes to, how many electrons are in the final energy level of chlorine. That's going to be important for us later. So I'll give you some time to do that now. Okay, I hope you took some time to pause and draw out chlorine. Here, chlorine has a total of 17 electrons. Alright, so chlorine has 17, which means that when we go ahead and draw it out, we're going to have 2 in the first energy level, 8 in the second, and then 7 in the last energy level. Okay, now this is something that you can also see here, that here it says that we have 2 in the first, 8 in the second, and 7 in the last. Okay. The next one that I'd like you to go ahead and pause and take the time to do is going to be for potassium. Okay. So go ahead and do the one for potassium, which is this one right here. So pause it and give it a try. Alright, and those that just want to go ahead and enjoy the show, here we have potassium. Notice we have K in the middle, 2 in the first energy level, 8 in the second, 8 in the third, and that last one is going to be on the outside all by itself. Man, it's all lonely. It probably wants to escape. That's what's probably going on. Alright, and so this is how we're going to go ahead and view energy levels in the atom. A couple of questions that I might see is, do you have to draw X's? And the answer is going to be yes, you do want to draw X's instead of dots, because, this is the way that the ACE program wants to work it, and since I am an ACE teacher, I want everyone to do it that way, so that when you come and take your ACE courses, you can go ahead and have an easy time of it. And then the other thing is that for this one, yes, you do want to go ahead and draw them out, and anytime it's requested that you draw them out, I actually do want you to draw it out. Okay. That's going to close us out for this lecture section, and I hope you all have a wonderful day, especially those of you that are going to find the lazy way.